Today, on how it's made. Matches. Matchmaker, matchmaker, make me a match. Carousel horses. This one's for the naysayers. Fine porcelain. China that's not made in China. And automobile fuel tanks. Fill her up. Lighting a controlled fire was not always easy. Only 200 years ago, you'd rub a rock on steel to create sparks. Then the stunning discovery that combining certain chemicals can ignite fire. Putting these chemicals on handy little sticks, well, nothing quite matches that. The first matches left behind a nauseating odor. But today, they're safer, and the smell dissipates in seconds. To make matchsticks, this company starts with recycled paperboard, which is inexpensive and thick enough to support the weight of chemicals on one end. A stamping press partially cuts the paper, creating stems. As we see in this view from inside the machine, a die first cuts the stems, and then a blade slices through the sheet widthwise, making strips of 120 stems each. At actual speed, it's all just a blur, as the press makes nearly 500 strips per minute. Next, the strips move through a bath of hot wax. It soaks into the stems about 1/3 of the way up. Then they dry in an oven for 15 seconds. When you light a match, the wax slows down the burn speed of the chemicals, sustaining the flame for 4 or 5 seconds. Those chemicals are gelatin and silica to bind the chemicals to the stick, potassium chlorate and animal protein glue for oxidation, sulfur to fuel the flame, and 2 fillers. They mix 317 kilos of the chemicals in a large vat with hot water. This is enough to make the chemical batter for 25 million match heads. A conveyor runs the matchsticks through the batter to coat their tips. 3 rollers in the tank raise the surface of the batter, the first to ensure the front and back of the heads get covered. The third rotates faster to remove excess batter as the heads leave the tank. From there, the matchsticks travel a distance of 365 meters while fans air dry them. The factory temperature is a comfortable 22 degrees Celsius, just what's required for the chemicals to dry and harden. These minerals are silica and red phosphorus. Add a little glue and you've got what's called friction, the material in the strip you rub the match against to make the head ignite. To make these striker strips, as they're called, a steel wheel rolls friction onto paper that's moving through a cutting press. This isn't the same paper from which they make the matchsticks. It's a higher quality, non-recycled paper, suitable for color graphics, because many clients order custom printed matchbook covers. Another press with rotary blades slices through the paper, creating segments that are 10.7 centimeters long. That's the length of an unfolded matchbook. Now, back to the matchsticks. A worker arranges the strips into layers of 2. A conveyor then feeds them into a machine that'll attach them to the matchbook covers. The machine performs several tasks. It cuts the matchstick strips into rows of 10 matches each. And it cuts the matchbook covers to their final width of 3.8 centimeters. The machine folds the matchbook covers over 2 rows, or 20 matches, then inserts one strong staple through all 4 layers. Next, a conveyor moves the assembled matchbooks to another machine that counts them and creates 2 side-by-side rows of 25, ready for boxing. This company also makes its boxes out of recycled paperboard. Each one holds 50 matchbooks and sells for about $1. That's $1 for 1,000 matches, or just a penny to light up 10 times. Centuries ago, soldiers tested their cavalry skills astride the rim of a large horizontal wheel. Eventually, Europe's wealthy elite saw this as entertainment and turned the practice into a fabulous pageant. Nowadays, you can ride a whole menagerie of animals, but the star of the carousel is still the horse. Their life revolves around a fairground, but they're born here, on paper. A craftsman draws a pattern of the horse's silhouette, then fills it in with a saddle, straps, and a harness. Some models may include a shield, a coat of arms, or even flowers. Another craftsman then glues together blocks of linden, wood that's lightweight and easy to carve. He stacks 4 of them to create what's called an end block. It'll form part of the horse's body, what's known as the core. He clamps the blocks together to compress them, and he lets the glue set for 45 minutes. The finished core includes 2 end blocks sandwiched by top, bottom, and side panels, plus 1 wooden piece they'll carve into a saddle. The middle of the core is hollow. On a carousel with 50 horses, this trims the overall weight by up to 3 tons. After covering the core with carbon paper, the craftsman lays the pattern on top. He traces the pattern with a leadless pencil called a stylus. The carbon paper underneath transfers the drawing onto the wood. He'll follow these lines to cut out the basic shape of the horse. Later, they'll carve most of the finer details by hand. Using a bandsaw, he slices the core carefully along the lines. Next, he drills a hole for the pole that attaches the horse to the carousel. Here, a craftsman uses what's called a carving duplicator to create the head. Following a template, the machine sculpts a block of wood into the horse's head, a painstaking process that takes 90 minutes. The duplicator can carve up to 4 heads at once. It also adjusts to carve some finer details into the larger pieces, such as the core. They use something called a parting tool to shape the decorative tassels on the bridle. This one has a fanciful design, what an Arabian horse would typically wear. The craftsman has a huge arsenal of tools at his disposal to create all kinds of special features, such as a flowing, wind-blown mane. The tools are sharp, and they're precise enough to sculpt even tiny, intricate parts, such as eye sockets, nostrils, and teeth. After applying polyester adhesive putty in the eye sockets, he adds 2 glass eyes. Unlike real horses' pupils, which are oval in shape, these have round pupils for a friendlier look. A carousel horse is roughly half the height of a real horse, but the size of its feet is true to life. So workers nail on authentic iron horseshoes. These prevent the wood from chipping under the feet of riders who get rowdy in the saddle. Wooden pegs temporarily connect the head and tail to the body. Once workers verify the alignment, they'll glue the sections together. After sanding down the entire surface, the paint job begins. First, 3 coats of white primer. This highlights any imperfections the sanding missed. Once that's done, the artwork begins. This horse will wear a bright, multicolored harness. Its coat will be in different shades of the same color for a realistic look. It takes up to 5 coats of paint to get it just right. Up to 7 coats of varnish will keep the horse looking beautiful for decades. After 2 months of work, assuming there was no horsing around, these striking creatures are ready to make their rounds. Porcelain is often called China after the country that invented it more than 1,200 years ago. It looks delicate, but is actually the hardest type of ceramic material. It's even used in electrical insulators because it withstands very high heat. But most people think of porcelain as decorative. This company makes 40 different porcelain items. It all starts with a sketch of the piece, in this case, a teapot. After that, a master mold of the piece, a negative made of plaster. Craftsmen use it to make a production mold. Porcelain begins as powder, a blend of 3 minerals, quartz, kaolin, and feldspar. The workshop mixes this powder with water to make a wet paste called slip. A craftswoman fills the mold with slip. Within 10 minutes or so, the porous plaster absorbs the water, leaving a crust of hardened slip. After pouring the rest out, she waits another 30 minutes for the crust to continue hardening. Then she peels away the mold and gets a first look at her teapot. Here, she removes excess crust from a different mold for the spout. She waits about 10 minutes until the spout is hard enough to handle, but still soft enough to sculpt. With a utility knife, she carves open the end of the spout. With a little water and a sponge, she smooths out the edges and curves the rim. Next, she extracts the handle from a third mold. Then she pierces 12 holes in the spout side of the teapot to filter out the tea leaves when you pour. She brushes on some slip to attach the spout and the handle. This model has a wedge along the collar to help align the handle correctly. Other designs have small notches instead. She brushes on more slip to ensure the parts will bond, then sponges the surrounding surface to smooth out the drips. After the piece dries for 2 more days, she carves away the lines along the handle and under the spout and sands down the rim. They make some pieces using a pressure casting system. The mold's made of resin and tiny polyester beads that create pores which absorb the water in the slip. After a hydraulic press closes the mold, the machine injects slip into the cavity. 12 minutes later, a craftsman uses a suction plate to remove what will become a serving platter. He places the piece on a plaster block. The porous plaster lets the underside dry without leaving marks. They fire the items in a giant kiln. The kiln heats up gradually, taking 8 hours to reach a searing 1,000 degrees Celsius, then 12 more hours to cool down. Firing hardens the porcelain and enables it to better absorb a coat of enamel. After brushing off any dust, the craftsman dunks each piece in enamel, a protective coating. The porcelain absorbs it right away, and this glaze turns into a shiny skin once the pieces are fired again. She handles each piece in a particular way to avoid leaving drip marks. In the second firing, they make the porcelain pure white by carefully controlling the air in the kiln. Reducing the oxygen level removes any undesirable colors. This time, the temperature is higher, 1400 degrees Celsius. It shrinks the pieces by about 15%. After a quality check, a craftsman applies the company logo with a transfer decal. The logo melts in when the plate goes back in the kiln for another 12 hours at 850 degrees Celsius. In the end, the porcelain is translucent enough for light to shine right through. Other pieces offer more illustrated displays for a truly fine dining experience. Considering how much it costs to fill them, it's no wonder today's gas tanks are made to be tough. Factories design a gas tank to safely fit a wide range of vehicles. Worldwide, the industry makes 60 million tanks a year for new cars and trucks, and millions more to replace older damaged tanks in existing cars. Making a gas tank begins with a simple sheet of steel. It's nickel-plated to make the tank rust-resistant. A worker places the steel in a hydraulic press that applies 800 tons of pressure. This compresses the sheet between two dies that shape the bottom half of the tank. The press forces the male die up against the sheet and into the cavity of the female die. To make the top half of the tank, or different size tanks, they simply change dies. On the tank's top section, a stamping press imprints information such as the product and lot numbers and the manufacturer's name. A hydraulic punch then pierces two holes, one for a tube to fill the tank and another to vent it. This machine makes an opening for a component called the Fuel Delivery Module, or FDM. It'll send fuel to the motor. A conveyor moves as many as 180 top sections per hour to the next production phase. There, a worker uses a steel and nylon jig to install a steel ring that'll position the FDM. He spot welds the ring in 6 spots, fusing it to the top section. 2 notches on the ring will align the FDM properly. Workers tack the top and bottom sections together, aligning them properly for the comprehensive welding that follows. 2 metal wheels compress the sections together and water cools the area as a machine called a seam welder fuses the upper and lower halves of the tank. Using a gas torch, a worker fuses a steel tube to the tank with lead solder. This is the filler tube into which you insert the gas nozzle when you fill up at the pump. Fuel flows in and air vents out through the tube simultaneously. A sensor automatically shuts off the gas pump when the air pressure inside the tube reaches a certain point. Most tanks fill only to about 80% capacity to leave room for vapors caused by hot weather. Robots weld the tanks destined for brand new vehicles because the work has to be precise and consistent in order to aid the assembly line robots at the auto plant. The human welded models are sold to auto repair shops as replacements for damaged tanks. They don't require the same precision because a mechanic does a custom installation. When the robots finish welding the tanks, they transfer them to a conveyor belt that moves them to the next production phase. There, a worker attaches a tin-plated venting tube. Tin makes it rust-resistant. He adds a steel component called a baffle to the bottom section of the tank. This reduces the sloshing of fuel inside the tank. The result? Less noise for the driver and less metal fatigue for the tank. They're usually just for tanks found in larger vehicles, like SUVs and small trucks. A worker now places the top section onto the bottom section, pulling a hose through the opening in the top. This hose will connect to the FDM. After a welding machine fuses both halves together, another machine bends the sides downward. This gives designers extra space to work with. They test every tank for leaks by dunking it underwater. After blocking all the holes in the tank, they pump a little extra air inside it. They shine bright spotlights and look for bubbles in the water. If air can escape, so can gasoline. No bubbles, and the gas tank passes inspection. Only then is it ready for shipping and a starring role in your car.